In today's lesson, we are looking at continuity again, but instead of at a single point, we are looking at over an interval. So what we want to do is look at a function and decide, so what intervals is it continuous? So what we want to look for first are where are there restrictions? So where is it not continuous? And then we can be able to write out the interval that it is continuous. So on this example, on which intervals is the function continuous? So what I'm going to do is factor. So x squared plus 8x, or minus 8x plus 12, that is going to factor to x minus 6 times x minus 2, and that is over x minus 2. So when that happens, this cancels, so that creates a whole at x equals 2. So after these cancel, there's nothing left over in the denominator, and I'm left with this. That is a continuous function, but there's just that whole at x equals 2. So this function is continuous from negative infinity all the way up to 2, but it doesn't include 2, and then it also goes from 2 to positive infinity. So this is the interval that function is continuous. It's also basically just asking what is the domain of that function. So we are going to continue that, basically just finding the domain of each function, which is will at the same time be showing us continuity over an interval. So if I have f of x equals the square root of 2x plus 5, what we have to do is look at what are the restrictions of that type of function. Well, I know I cannot take the square root of a negative, but I can do square root of 0, and I can do square root of positives. So if I look at the number underneath, 2x plus 5 has to be greater than or equal to 0. So if I solve for x, I'll have all x values greater than or equal to negative 5 halves. So I'm going to turn this inequality into interval notation. So all x values greater than negative 5 halves. So the smallest number is, so negative 5 halves, including, so I've got my bracket, and I'm going to go all the way up to positive infinity. So there is the domain. That is when this is continuous. All right, so now let's look at f of x equals, I have the square root again of x plus 1, but this time it's over x squared plus x minus 12. So what you want to do is just look for where are you going to have restrictions. So in the numerator only matters because of the square root. So once again, I have x plus 1 has to be greater than or equal to 0. But then also, now I have a variable in the denominator. So my denominator, x squared plus x minus 12, cannot be 0. So let's solve both of these. Here I'm going to factor. This factors x plus 4 times x minus 3, and this cannot be 0. Therefore, x cannot be negative 4, and x cannot be positive 3. Okay, if I solve this one, So x has to be greater than or equal to -1. So this greater than or equal to -1, so I can't have any smaller numbers than -1. So over here, this number already doesn't even count because it's not in this domain over here. So greater than or equal to -1, but also it can't be 3. So interval notation, the smallest number is -1, and it's including -1. And I can go up to 3, but I cannot include 3. And then it will also go from 3 to positive infinity. All right, next example, let's look at a logarithm. F of x equals ln of 3x minus 1. Okay, so logarithms, if you remember, I cannot have logarithm of 0 because, let's see, e to what power equals 0? That can't work. And ln of a negative number can't work because base e is a positive number. To what power is -1? Not going to work. So when you're taking the logarithm, that 3x minus 1 has to be greater than 0, but cannot be 0. So if I solve this, I'll have x is greater than 1/3. So all values starting, well, at 1/3, but not including 1/3, and then all the way up to positive infinity. Okay, last example. F of x equals 5x plus 2 over 3. So where are the restrictions of my domain? Well, I have no square roots, I have no logarithms, I have a rational function, but I have no variable in the denominator. So this is actually just disguised as a linear function. It would be like 5/3 x plus 2/3. Just a straight line. So this is continuous. The domain is all real numbers. And another way to write this is from -infinity to positive infinity. So it is fully continuous. So there is the full lesson on continuity over an interval, also referred to as finding the domain of a function.